Lesson 110, the intersection of a line and a plane. So in this lesson, we're going to focus on how a line can intersect with a plane. So think of you have a piece of paper, maybe, and then your pen. How can you arrange two things, and how can they, what kind of configurations can you come up with, right? So when you have a line and a plane, the line can, cut through the plane, so there is a point of intersection. Or if the line is parallel to the plane, then it won't intersect with it at all if it's not coincidental, okay? And the line can, of course, be aligned on this plane, so there will be infinitely many points of intersection in that case, okay? So 3 different cases it is. So example 1, we have the intersection of a plane that we're looking for, and the line given in Cartesian form. The best way to tackle this problem is to first rewrite the Cartesian equation of the line into parametric form, because that way you will have an expression for x, y, z, which can be substituted into the equation of the plane. Okay, so here it is. So rearrange the equation of the line into parametric form. Okay, so remember, we can pretend that there is some sort of a parameter s or t, whatever. And so we have x, 2s plus 1 equals to x. And then y would be 4s. And z would be negative 3s minus 6. Okay, so with these parameters, we can substitute them into the equation of the plane. Which has x, 2s plus 1, plus 11y, so 4s, minus 2, negative 3s, minus 6, and that's equal to 39. Let's expand. I have 2s plus 1 plus 44s minus or plus 6s plus 12. That's 39. 44 plus 6, 50, 52. So this gives me 52s equal to, 12 plus 1 is 13. 39 minus 13, that's 26. So s, the parameter, is equal to 1 over 2. Okay. So in this case, we know that there is one unique parameter that will, make the line and the plane cross, basically. So we can find that point of intersection by substituting s into the equation or the parametric equation then. Okay, so let's go to the side here. Okay, so what do we have? We have x equals to 2 times a half, 1 plus 1, 2. Y equals 4 times a half, 2. And z equals to negative 3 over 2 minus 6, so negative 15 over 2. Therefore, there is a point of intersection at 2, 2, and negative 15 over 2. Okay, so the idea here is we have a plane, we got our line kind of like protruding through here, meeting at point P2 to negative 15 over 2, like that. Okay, if I want to get fancy, maybe I can like shade in the plane like that. Okay. Moving on, example 2. This time, let's find the intersection of the plane and the line given in parametric form. And just like the first example, we can do some substitution here. Okay, so sub the parametric equations into the equation of the plane this time. Okay, so 4x becomes 4 times 1 plus 5t plus 6y, so 6 bracket 1 minus 3t plus z, which is 2 minus 2t. That's equals to 12, expanding 4, 20t, 6, 18t, plus 2 minus 2t is 12. Let's see, so 20t minus 18, 2, so minus 2, 0t. 4 plus 6, 10, plus 2, 12. The other side, this is 0. Well, 0t equals 0. This is always true. So consider the 3 possible ways a line can intersect with a plane, right? So in the first example, we saw a point of intersection, so only one parameter works. And then there is the possibility that, the line is not on the plane and they're parallel. Not the case, right? Because that gives us no solution. But this actually gives us infinitely many solutions, which means that this line actually lies on the plane. So let's write this down. Hence, there are infinitely many solutions, and the line is coincident with the plane. As a result, the solution is basically the line itself, right? In parametric form. So 1 plus 5t, 1 minus 3t, 2 minus 2t. Okay, so let's maybe represent this using a diagram. So here's the plane, and the line basically lies on this plane. All right. Example 3. Find the intersection of the plane 2x plus y minus z equals to 3 and the line in Cartesian form. How many different flavors can we get? Not that many, right? So let's label them. We know parametric form works best. So here we go again in parametric form. So if I let this to be t, x would be 2t plus 1, y would be 1t plus 1, and z would be 5t plus 1. Okay, and then let's substitute this into equation 1. So 2x, 2 times 2t plus 1 plus y, so t plus 1 minus z, 5t plus 1 equals to 3, 4t, 2t, 1 minus 5t minus 1 equals to 3. Let's see. 4t plus 1t, 5t minus 5t, 0t. 2 plus 1, 3 minus 1 is 2. And we have 3 minus 2, 1. Can I ever multiply a number by 0 to get 1? No. So we say that this is never true. And from this, we can deduce that there is no solution. And of course, we now know that this line must be parallel, but not coincidental to the plane. Okay, and the case that we're talking about is like that. Here's the plane. Here is my line. It's kind of like floating above the plane. Okay, so L and this is L are non-coincidental. Like that. Okay, again, big and fancy. All right. Here's example 4. Determine the intersection of the given plane with the z-axis. In other words, we are looking for the z-intercept, okay? So we know that in 3D space, if we kind of like sketch out the coordinate system, y and z, the z-intercept would be any point on the z-axis, which means that we can let z equals to 0, 0, any number. Let's call it C, okay? Be the point of intersection. Just like that, okay. So now I know that I can just set 0, 0, Z equal to the equation of the plane, which is 1, negative 1, 2, plus S times 1, 2, 1, plus T times 2, 0, 1. Okay. We can come up with 3 parametric equations here. 0 equals to 1, plus S plus 2T. 0 is also equal to negative 1 plus 2s, and then C is equal to 2 plus s plus t. And here we go. Okay, so obviously from the second equation, we can identify s as being 1 over 2. If there is a point of intersection, or if there is a z-intercept. Okay, so now let's substitute this value of s into equation 1. That will allow us to find the value of t. So 0 is equal to 1 plus 1/2 plus 2t. I have negative 3/2 equals to 2t. T must equal to negative 3 over 4 then. Okay, and then doing the same now this time to equation 3, which will allow me to find the value of C in this case. So sub S equals to 1/2 and T is equal to negative 3 over 4 into equation 3. I've got C equals to 2 plus 1 over 2 minus 3 over 4. So what have we got here? We got 8 to 3 over 4, 7 over 4 it is. Okay, therefore the plane intersects the z-axis at the point 0, 0, 7 over 4.